Okay, this is the second question that been asked. It's actually more difficult than the previous question, but anyway, let us do this. A 2.2 kilogram projectile is fired upwards at an angle at 33 meters per second. It gains a maximum height of 30 meters above level from which it was fired. Calculate two things. Number one, the initial kinetic energy and the horizontal speed at maximum height. So maybe you can start off by sketching the trajectory. So you can expect that if you have one projectile being launched, this should be the curve. This is what we call as the projectile. Okay, it's a bit crooked, it's a bit difficult, and we've launched with angle, and it moves at 33 meters per second initially. So you can call this V. It launched at 33 meters per second. Number one, if you want to calculate the initial kinetic energy, so one thing that you can consider is that always you can put the ground here to be having the zero potential energy. Alright, and if that's the case, it is pretty simple to find the kinetic energy. Kinetic energy is always half mv squared. Okay, mass 2.2 and the speed 33 square. So the answer here would be up to 2 significant figure 1.2 to the power of 3 joule. So this is pretty simple. Alright, and I can tell you the total energy here at the point of release here, it is 1.2 to the power 3, because the total energy in this case is all equal to kinetic energy, as we have defined the potential energy here to be 0. Alright, so we'll need to use that info on the solving the part B. Find the speed, the horizontal speed at the maximum height. So maybe this is the trajectory at the point that at the maximum height here, I can tell you that the horizontal speed, I might want to call it Vx. V subscript x, they are asking you to find what is the value. Alright. So how do we do this? We can use the conservation of mechanical energy. Again, the E total energy would be, we do know this value. This is the total energy, and it is the same for every point up to where it lands here. Okay. So at this point here, at the maximum height here, which is 30 meters above the ground, we can use this information that at the highest point here, you do have potential energy, and at the same time, you do have kinetic energy. And in this case, the velocity here, the speed here is Vx squared. The Vy will be 0. The vertical speed is 0. Because at maximum height, remember, the vertical speed will always be 0. Alright, so let us continue the mathematics. 1.2 to the power 3. Potential energy is mgh and plus half mv squared. Okay, so the mass 2.2, g 9.8, and the height here, the h here would be 30 plus half m 2.2, and the Vx here, you have to find what is the Vx, and this is Vx squared here. So you have to do the mathematics. In this case, if I want to simplify it, alright, if you take this potential energy, bring it to the left hand side, you will have a value of about 553.2. Try it yourself. And this case will be 1.1 Vx squared. So you have to find the Vx value. Up to 2 significant figure, I will have 22 meters per second. So this is the speed at the maximum height. Alright. The horizontal speed is non-zero. The vertical speed is 0. So that's how you do this question. This will be the true answer. Thank you.